All right, this video is for Owl Math here. I have enjoyed your videos and I thought I might demonstrate for you the ways that we can do insane trig integration using the complex definition of trig functions. So e to the ix, I'm technically supposed to use a z variable, but nobody cares, is cos x plus I sine x. And I am way too lazy to prove that. That would make this 80 times longer. The interesting thing is, what if you plug in a negative for the x variable there? I'll just move that out to the front, e to the negative ix. Well, if your input is negative, cosine is an even function, so it gives 0 hoots, versus sine is an odd function, so you can pull the negative out to the front. If we, on the one hand, take these two equations and add them, we will get e to the ix plus e to the negative ix is equal to 2 cos x. In other words, cosine of a complex input is e to the ix plus e to the negative ix over 2. On the other hand, if we subtract these, then we get e to the ix minus e to the negative ix is equal to 2I sine x. In other words, sine x is equal to e to the ix minus e to the negative ix over 2I. Those are the complex definitions of the basic trig functions. So I saw on your channel that you had some problem, like, I'm probably going to say this wrong, I think it was sine 6x cos 2x is a good example. Well, I'm going to do you one better, and I'm going to do the integral of sine mx cos nx, and do all of them at once for any constants m and n. What we're going to do is we're going to take these definitions and we're going to say that sine makes e to the I mx minus e to the negative I mx over 2I, and cosine makes e to the I nx plus e to the negative I nx over 2. Still haven't integrated yet, but let's FOIL first and multiply those out. We can just add exponents. Let's take out the 1/4 I out of all of that. And if we FOIL, we will get e to the, well, the I and the x are in common, so m plus n. That's the f in FOIL. First outer is going to be e to the I and x, and the m is positive and the n is negative. And then the inners is going to be negative e to the ix, and they're both positive, versus the lasts is negative, and both exponents are negative. So let's take that negative out, and then their m and n are both positive. All of that, and I still haven't integrated yet. So now if I integrate, let's just treat I like a constant, and the integral of e to the u, if it's e to the ux, is 1 over u e to the ux. So that means that we can just get e to the ix m plus n over I m plus n. That's the first one. The second one is going to have e to the ix m minus n divided by I times the quantity m minus n. And first, outer, inner. I don't think I did that right. I think I needed a negative there, and that's why this would be m minus n. And so now when I do it, it's going to make a negative on a negative, so that'll be plus, but the exponent will stay negative, and subtraction. And I already dealt with the negative, but I didn't deal with the I, m minus n, and then a negative and a negative will make a positive, e to the negative ix m plus n, all over, I dealt with the negative, I m plus n. All right, so in some horrible world, that is a satisfactory answer, but not to me. I look at this and I think we can come back to basic trig functions, where the plus, the m plus n right here, and the m plus n of right here, that fits the definition of cosine that we talked about earlier. Now I need a 2 on the, actually, all of these have an I, so let's get rid of, let's take all of these I's out and get another I, and then two I's make a negative. Okay, so regrouping here. We've got a negative 1 over 2 because I need to steal a 2 for the denominator. This one, both of those purple ones have, or pink, I'm colorblind, have m plus n. So I'm stealing this 2 right here to get e to the ix m plus n plus e to the negative ix m plus n. Those exponents are the same as each other except negative, so that's the definition of cosine. And then in another color, this is another cosine here with the m minus n's. These two terms are both m minus n. So that 2 that I stole inside the parentheses, m minus n, can go in the denominator right there. E to the ix m minus n plus e to the negative ix m minus n, like that. Altogether, this is negative 1/2. That is simply a horrific definition of cosine of the quantity m plus n times x over m plus n. And this is a disgusting definition of m minus n times x all over m minus n. Meaning, following that formula, your problem that you did in an OWL 3 video is negative 1/2, 6 plus 2 is 8, and 6 minus 2 is 4. Ta-da!